Look up at the night sky. What do you see? If you are far from the city lights, you might see a river of stars stretching across the darkness. This is the Milky Way, our home galaxy. It contains billions of stars, and each star could have planets orbiting it. For thousands of years, humans have looked up and wondered. We have asked the same simple yet profound question: are we alone? This question has driven our stories, our science, and our deepest explorations. But in recent decades, science has started to ask an even bigger question. What if the question isn't just about other life in our universe? What if there are other universes entirely? This idea might sound like science fiction, but it is an idea that some of the world's leading physicists are seriously considering. Imagine you are on a small boat in the middle of a vast ocean. You can see the water all around you, stretching out to the horizon. As far as you can see, there is only water. You might think that this circle of water is the entire world, but you know it isn't. You know that beyond your horizon there is more ocean, and eventually there is land. Our view of the universe is a bit like that. We can only see so far. The light from very distant objects has not had enough time to reach us since the universe began. This boundary is our cosmic horizon. Everything we can see, every star, every galaxy, exists inside this observable bubble. It is enormous, but it might not be the whole story. The universe is likely much, much bigger than what we can see. It could stretch on forever, far beyond our cosmic horizon. This idea alone is mind-boggling. But modern physics takes this idea a step further. What if the universe doesn't just stretch on forever? What if beyond our horizon the universe itself changes? What if there are other regions so far away we will never see them, where the very laws of nature are different? For centuries, we have gradually been demoted from the center of existence. First, we learned the Earth was not the center of the solar system. Then we found our sun is just one ordinary star among billions in the Milky Way. Then we discovered our galaxy is just one of billions in the observable universe. The multiverse is the next logical, if terrifying, step in this cosmic demotion. Our entire universe might be just one of an infinite number of others. Imagine a huge pot of boiling water. Bubbles of steam form and expand within the water. Our universe is like one of those bubbles. The boiling water is the eternally inflating space-time, the metaverse that spawns new universes. New bubbles are constantly forming, each one a self-contained universe unaware of the others. These bubbles would expand and evolve on their own, a cosmic foam of countless worlds. What would these other universes be like? The possibilities are almost limitless. Some might be very similar to ours, with stars, galaxies, and maybe even life. But others could be radically different. Imagine a universe with 2 dimensions of space instead of 3, or a universe where gravity is a repulsive force pushing everything apart. Most of these universes would likely be sterile and uninhabitable, dead bubbles where nothing interesting ever happens. The laws of physics would simply not allow for complexity to arise. To understand how bubble universes might form, we need to travel back in time. We must go back to the very first moment of our own universe's existence. Our best theory for this instant is called cosmic inflation. It suggests that in the first fraction of a second after the Big Bang, our universe went through an astonishing growth spurt. It expanded faster than the speed of light, swelling from a size smaller than an atom to something larger than a galaxy in an instant. This incredible expansion was driven by a powerful energy field, often called the inflaton field. This field filled all of space and acted like a kind of anti-gravity, pushing everything apart with immense force. However, like any energy field, it can have fluctuations. In the cosmic foam, a random fluctuation can cause a small patch of the energy field to relax to a lower energy state. This is the seed of a new universe. When a patch of the inflating metaverse drops to a lower energy state, the trapped energy has to go somewhere. It's released in a tremendous burst, a hot, dense fireball of matter and radiation. This is what we call the Big Bang. The theory that inflation might never completely stop is known as eternal inflation. It suggests that while inflation ended for us, creating our bubble universe, the wider metaverse continues to expand at that incredible superluminal rate. The inflating metaverse is like a factory for making universes, a factory that never shuts down. It is constantly producing more space, And within that space, new universes can be born. Our universe is just one product that rolled off this cosmic assembly line about 13.8 billion years ago. The creation never stops. The physics that governs each new universe is determined at the moment of its birth, and the outcome appears to be random. To explain this, physicists developed an idea called the string theory landscape. Imagine a vast landscape with towering mountains and deep valleys. Each valley represents a stable set of physical laws, a possible way a universe could be. When a new bubble universe is born, it's like a ball being dropped onto this landscape. It will roll down and settle into one of the valleys. The specific valley it lands in determines everything about that universe: the strength of gravity, the number of spatial dimensions, the types of particles that exist. Picture a universe where gravity is 1,000,000 times stronger. In such a place, stars would burn through their fuel in an instant and collapse into black holes. The universe would be a dark, violent place with no chance for planets to form, let alone life. Now, imagine a universe where gravity is much weaker. Stars and galaxies might never form at all. Clouds of gas would just drift apart forever, never clumping together to ignite the first stellar fires. The strong nuclear force, which holds atomic nuclei together, is another finely tuned parameter. If it was slightly weaker, only hydrogen would exist. Complex elements like carbon and oxygen and iron, which are essential for planets and for us, could never be forged in the hearts of stars. Our universe exists in a Goldilocks zone of physical laws, where things are just right. Most other bubbles in the foam would likely not be so fortunate. When a new bubble universe is born, it is as if a cosmic die is rolled, and one of these sets of laws is randomly selected. The result is a multiverse filled with an incredible diversity of physical realities. Some might be subtly different from ours, perhaps with slightly different particle masses. Others would be unrecognizably alien, governed by forces and principles we just cannot even imagine. The discovery of the multiverse would represent the single greatest shift in human perspective since we first understood the Earth was not the center of everything. But how do you find evidence for something that, by its very nature, might be forever beyond our reach? Many skeptics argue that the multiverse is not science at all, but rather a form of philosophy or metaphysics. They contend that since we can never travel to another bubble universe, and since they exist outside our own space and time, the idea can never be directly proven. However, a new generation of cosmologists believes that the situation is not entirely hopeless. They argue that while we can never visit another universe, we might be able to find indirect fossil evidence of its existence. Our best hope for finding this evidence lies in studying the cosmic microwave background, or CMB. The CMB is the oldest light in the universe, a faint afterglow from our Big Bang. The most dramatic piece of evidence for another universe would be the discovery of a cosmic collision. If our bubble universe collided with another in the distant past, it would have been a cataclysmic event. This collision would have sent a shockwave of energy rippling through our young universe. This shockwave would have left a lasting impression on the cosmic microwave background. Scientists predict it would show up as a distinct circular patch on the CMB map, a disk that is either slightly hotter or colder than its surroundings. Beyond the light of the CMB, there is another messenger from the early universe: gravitational waves. These are ripples in the very fabric of space-time, predicted by Albert Einstein. The formation of a bubble universe is an incredibly violent event. The sudden change from a high-energy, false vacuum to a low-energy, true vacuum would create a storm of gravitational waves. This is where future space-based gravitational wave observatories, like the planned LISA mission, come in. LISA will consist of 3 spacecraft flying in a triangular formation millions of kilometers apart. If LISA detects a background hum that cannot be explained by anything in our own universe, it could be the sound of the multiverse. For all of human history, we have defined ourselves against the backdrop of one single vast and lonely universe. Our stories, our religions, and our scientific endeavors have all been framed by this assumption. The idea that our entire cosmos, every star, every galaxy, every black hole, is just one insignificant bubble in an infinite foam of other universes is, well, profoundly humbling. If our universe is just one of many, it suggests that the conditions we see around us are not special or divinely ordained. They are simply the result of a cosmic lottery. The laws of physics that allow for our existence are not a miracle, but a statistical inevitability. In such a cosmos, we are forced to create our own meaning. If the universe does not provide a purpose for us, then we must define one for ourselves. Our meaning is not something to be discovered out there in the cosmos, but something to be built right here, through our actions, our relationships, and our quest for knowledge. The significance of our lives is not diminished by the existence of other worlds. It is defined by what we do in this one. Our purpose is found in the love we share, the art we create, the kindness we show, and the understanding we seek. Our meaning is to be the universe's way of knowing itself, right here, right now. And that, in any universe, is a remarkable thing to be. The existence of a multiverse could offer a strange kind of cosmic hope. It implies that the universe we inhabit is not the only chance for life and consciousness to arise, but this understanding should inspire a greater appreciation for our world. Our planet, our sun, and the delicate balance of our cosmic neighborhood are the result of winning a cosmic lottery with unfathomable odds. It underscores our responsibility to cherish and protect the one habitable world we know we have. Whether we are alone in this universe or our universe is just one of many, our responsibility remains the same. It is to cherish our improbable existence, to protect our precious world, and to never stop asking questions. We have journeyed to the very edge of modern physics, to a place where science, philosophy, and imagination meet. We have explored the astonishing idea that our vast universe might be just one small bubble in an infinite cosmic foam. The truth is, we do not know if bubble universes are real. The idea remains firmly in the realm of theoretical physics, a beautiful mathematical consequence of our current models. We stand at a frontier of knowledge, peering into a great unknown. The quest for the multiverse is a reflection of our species' innate and unquenchable thirst for knowledge. It is the same spirit that drove our ancestors to cross oceans, to chart the stars, and to peer into the heart of the atom. So the next time you look up at the night sky, allow yourself a moment to wonder. Think about the billions of stars in our galaxy and the billions of galaxies in our observable universe. And then, take one more step. Imagine that our entire unimaginably vast universe is just one tiny bubble floating in a cosmic ocean alongside countless others. Imagine the sheer variety of worlds that could exist, the different laws, the different dimensions, the different fates. This thought does not make our universe smaller. It makes reality infinitely larger. The universe, or the multiverse, is likely far stranger and more magnificent than our limited human intellect can fully comprehend. The universe, or the multiverse, may not care that we are here, but we can care. We can be its witnesses, its students, and its storytellers. The search for answers is what gives our brief moment in the cosmos its meaning and its magic. In the face of that boundless mystery, our own brief, improbable existence in this one lucky bubble becomes not less meaningful, but perhaps all the more miraculous and precious. We live in a remarkable time, a moment when we can seriously ask whether we inhabit a multiverse, and that alone is a triumph of the human intellect, and that in any universe is a remarkable thing to be.